Welcome to MyProjectBazaar.com. Now we are going to discuss about a project feature enhancement in visually impaired images. Now we are going to see the abstract of our project, and the feature detection, description and matchings are the essential components of various computer vision applications. Thus they have received a considerable attention in the last decades, and in the computer vision and image processing, the feature detection includes the methods for computing abstractions of image informations and making the local decisions at every image point, whether there is an image feature of a given type at that point or not. The resulting features will be subset of the image domain, often in the form of isolated points, continuous curves, or connected regions. And this image feature detection is very difficult in the visually impaired images. In the visually impaired images, the minute pixels in the region is very difficult to find out for the process. So, the edge detection process for the feature extraction is very inefficient. So, in order to detect the efficient features in the visually impaired images, the phase stretch transform is proposed to detect the features, and this feature enhancement process will provide a better feature values of the image. In that the proposed system, the input image is pre-processed and then the images tend to the phase stress transform. In that the kernel phase strength and the kernel wrap strength is constructed and applied for the efficient feature detection process. Finally, the obtained edges are overlaid on the image and compared with the conventional systems, and the comparison results which shows the proposed systems which performs better than the existing systems, and the performance measures values are measured in terms of accuracy, sensitivity, specificity, precision and recall. Let's we see the flow diagram of our project. In that flow diagram, first we are going to see the input image acquisition stage. In that image acquisition stage, the images are collected from the dataset for the process. So first the images in the datasets are not taken from the dataset for the process. Next stage is the image pre-processing. In that pre-processing stage, we are converting the images into resize and gray conversions. For the image resize operations, we are converting the input image into 512 cross 512 sized pixels for the process, and the gray conversion means we are converting the image RGB image into gray image. After that, the pre-processing stage, we are initializing the localization parameters for the mathematical calculations for the phase stress transform. So we are initialize the localization parameters. After that initialization, the low pass filtering is applied to the visually impaired image. For that, the low pass filter value is set. After that, applying the low pass filters, the PST kernel is constructed. In that construction, we are initializing the PST strength, wrap strength and kernel strength. After the kernel strength and wrap strength is constructed, which is applied to the input image, which is the low pass filtering image. So the PST is constructed and applied to the image. The PST applied image is obtained by the where the edges are found out in the given input image, which shows that on PST kernels. After that, the edges are obtained. The obtained edge image is overlaid on the input image, which shows that the PST kernel transform of the image. After that, the image overlaying, the performance of the system is evaluated. In that performance evaluations, we are find out the accuracy, sensitivity, specificity, precision, recall and F measure value of the image. Let's we see the running procedure of our project. If you want to run this project, just right click on the main file and select the run button. A dialog box will open, which consists of a visually impaired images. I said select any one of the image and select open button. And the images will get processed. So I just explain the images one by one. So this is our input image for our process. We are taking visually impaired images, and this is the resized image where we are changing our original size into 512 cross 512. So, and this is the gray image. We are converting the original RGB image into the grayscale image, and for the contrast we are using the adaptive histogram equalization for the contrast enhancement. So here we are enhancing the contrast of the image by using uh, his, adaptive histogram equalization, and this is the uh, applied PSG with kernel strength and wrap strength image. This is the PSG digital edge image. Here we are finding that the minute edge pixels are obtained. So by using the faceless transform, we are obtaining the minute pixels in that image. This is the image which shows that the PSD analog edge. For applying a low pass filter, kernel strength of the PSD transformation and the wrap strength of the PSD transformation, and the modified flag for the analog edge. So we are getting that analog edge image, and this is the PSD overlaid on the original image. So the obtained edge features are overlaid on the original image, and this is the conventional edge image by using the canny edge operator, which shows that the minute particles of minute edge pixels are not considered. So this is the conventional edge image overlaid on the original image. So the both the image PSD edge image and the canny image, which shows the huge differences, and this is the performance of the proposed system, which shows that the accuracy, sensitivity, specificity, precision and recall values, and this is the performance graph of the system, which shows that the performance values.